The first cation to test for is lead nitrate. So there's two test tubes there, both have lead nitrate in them. The first test is hydrochloric acid for a source of chloride ions. If lead is present, chloride will precipitate with the lead to give a white precipitate. Now the problem with this test is if the lead concentration isn't high enough, you won't get a precipitate. So one of the confirmation tests you can actually do is to try potassium iodide, because lead and iodine will form a yellow precipitate at a lower concentration of lead. So if we try this one, we get the characteristic yellow precipitate of lead iodide. So that's the confirmation test. So just remember, with lead, if your concentration is insufficient, you may not get a precipitate with the chloride ions. You'll need to do the confirmation test of iodide ions with the lead. The second cation we will test for is barium. So there's barium nitrate in each of those. To test for barium, you first use a sulfate. Now remember, barium and calcium will both form a white precipitate with the sulfate. So there we go. So to distinguish if it's barium or calcium, you then need to do a second test on the sample with fluoride, and the barium will not form a precipitate with fluoride, whereas the calcium will. The next cation to test for is calcium. So we've got calcium in these two. Once again, we test for calcium with sulfate. Just like barium, it should give a white precipitate with the sulfate. Okay, this one doesn't have a high enough concentration, so you do get issues there with concentration, just like we did with the lead. A confirmation test is fluoride ions with calcium, and this should give a white precipitate. There we go, you can see a white precipitate forming with the fluoride ions. And you do have a third test that you can use to distinguish barium and calcium, is the flame test. So calcium produces a brick red colour, whereas the barium produces a pale green flame colour. So that's a good way to distinguish between the two. The next cation test is between copper, iron 2 and iron 3+, and for all three of those you can use sodium hydroxide. You need to be careful with these three though, because the original solutions do have a bit of a colour. So the copper is slightly blue, and the iron 2 a little bit yellowy orange, and same with the 3. So when we test them with the sodium hydroxide, you should actually get different precipitate colours. So let's do the iron 2+ first. Sorry, let's do the copper first, and we get a blue precipitate. There it is. If we do the iron 2, we should get a green or white precipitate. There you go, that's turned a little bit green. I'll just pop a little bit more in there. Okay, so we're getting a green precipitate, and the iron 3+ should give us a brown precipitate. So these tests are quite good, and you get three nice clear precipitate colours that change colour a little bit, not much. Let's try a drop more. There we go. So now we've got the brown colour for the iron 3. Okay, confirmation test for the copper hydroxide is to use some concentrated ammonia. Now this stuff's pretty nasty, so we'll try and avoid it as much as we can. Okay, if we get some concentrated ammonia and add it to that precipitate, it goes a deep blue colour. So that is the confirmation test for the copper hydroxide. Add concentrated ammonia. The confirmation test for iron 2+ is to add acidified potassium permanganate. The potassium permanganate is a purple solution. It's actually stained the dropper there, but if we add the purple solution, it should be decolorized by the iron 2+ ions. Okay, so you can see the purple on the side of the test tube there, but when it hits the 2+, it decolorizes. So that is confirmed iron 2+. The confirmation test for iron 3+ is to add the thiocyanate ion, and when we do that, we get a brick red solution forming. So here we go, deep brick red colour there, confirms iron 3+.